All right, we are now recording. Let's get the slideshow set up from the current slide. However, we're not starting from this slide quite yet. We'll be there in a minute. Let me go over my announcement. I'm taking my physical science class on a field trip to Sanford Planetarium today, this afternoon. You can if you like. It doesn't. It's free. Okay. Okay. We're leaving at 12:30 and probably won't be back until around 3-ish. You want to go? Okay. Yeah. Okay. I figured you did. Okay. I was hoping you. Never mind. Okay. Okay. Now, what does that have to do with you? Well, this. It affects my office hours today. Not that we leave during my office hours. It's just that as soon as this class is over with, normally I have office hours 10:45 to 12:30. But today, as soon as this class is over with, I've got to book it over to the Birmingham campus, pick up the van, drive the van back over here, and be ready for that. So I'll be leaving sometime after 10:45, probably not getting there until after 11:15, doing whatever I need to do to get the van, and then coming back over here. I almost guarantee you I will not be back by 11:45. Possibly it'll be closer to 12 o'clock. So that means my office hours at the most are going to be 12 to 12:30, maybe 11:45 to 12:30, something like that. At the best they're going to be. So very short office hours today. Then we go to Sanford, we come back, we continue class, and class gets over with at 5. So if you can't catch me, say, between 12 and 12:30, you have to wait till after 5. But don't wait much after 5, because as soon as 5 o'clock comes, I'm booking it back to the Birmingham campus to turn in the van and then heading home from there. So very few office hours today. Maybe about a half hour right before my class begins. So just wanted to let you know that. Any questions on anything we've done so far? Okay. We didn't quite finish 4.3, okay? However, it's just one more example, and that's not on the slide set. So this is actually the slide set for 4.4, which is trigonometric functions of any angle, and we'll pick up this as soon as we finish the last example. But I needed some white space to write on, so we're going to write on this one. Example 10 on page 285. If there's no questions, solving a right triangle. Find the length C. Whoops, let me get my pen activated for dark purple. Here's the deal here. We have a ramp. I think it's a skateboard ramp. Okay? Now, this ramp is A units long. It's 4 feet high at the end. That's supposed to be a right angle there. Mine doesn't look like it. And here's C is the length that we're looking for. Okay? It says find the length C of the skateboard ramp shown in the figure and also find the horizontal length A of the ramp. One other piece of information, sort of hard to see, is that this angle here is 18.4 degrees. All right. Now, how in the world are you going to find C? Oh, there it is. No. How are you going to find C? Say again? Don't think it'll quite work, because you don't know A either. What's the name of the course? Oh, okay. And we're using functions, okay? Now, is there a trig function that relates the angle 18.4, the side 4 feet, and the unknown length C? C means... Absolutely. So say to me what you just said in a mathematical sentence. You get it? He's thinking about it. Jasmine Novus, is that right? Okay. I guess we've lost the other Jasmine. We haven't seen her in a few weeks, so I guess she's gone. Okay, so say again an equation that says sort of what you said. You said it. Huh? Sine of 18.4 degrees equal, this one, 4 feet. 4 over C. Is that what you said? Very good. Can we solve that for C? How? Second? Okay, let's isolate the C. And where do we want the C when it's by itself? In the denominator or numerator? Numerator. So we got to first get it out of the denominator. How do we do that? Multiply both sides of the equation by C. That will get it out of the denominator, and that gives you C times the sine of 18.4 degrees equal 4. How do we isolate the C? Divide both sides by sine of 18.4 degrees. Okay. That can all be done on a calculator. I'm not going to do that in my head. So pull out your old calculators, and this goes to 0. Goes to 1. So that'll be 4 divided by. Be sure you're in what mode? Degree mode. So once you're in degree mode, then do C divided by sine of 18.4. Equal. Now, if you have an old scientific, when you do that sine, you have to do the 18.4 first and then do the sine. So just keep that in mind. But do it however you can. What does C come out being? It'll be in feet because the 4 was in feet. Think it's going to be larger or smaller than 4? Much larger, because the hypotenuse is the largest length of any triangle, and 4 is the shortest. It looks like here, guaranteed it is. It's considerably larger than 4. Get an answer? Yeah, 0.3. Yeah, no, that's wrong. 4 divided by sine of 18.4 degrees. Are you in degree mode or radian mode?
I don't know.
Better check.
I don't have a good calculator. It's at home. I can't do it on my good calculator.
I got 12.69.
12.69. Let's call that approximately 13 feet. I'm sure the book uses more digits than that. They do 12.7. I said about 13. That's fine. 12.7. The reason I don't do it, well, this is given to 3 significant digits. That, though, is only given to 1. So if you wanted to stretch it and say 12.7, that's fine. If they had said 4.00 feet, I would have been happier. 12.7. I see why they're doing it, but actually they shouldn't. That's more precision out than you had coming in. But we're not going to argue about that. The second part says, find out the horizontal distance, A. How are you going to do that? Okay, you can do it that way. That would be the tangent. So give me the equation that says what you just said. Tangent of 18.4 degrees equal 4 A. Got it. And now we got to do the same type thing. Can you go straight to the answer almost? Yeah? Huh? It's not the same because it's a tangent, but you're doing the same procedure. What would that be? A is equal to You want to take every step? We'll take every step. Just give me something. Tell me something. Say again? Okay, so how do we get it there? Multiply both sides of the equation by A. Okay, we'll take every step. And then what? Divide by tangent 18.4. Okay, so A is 4 divided by the tangent of 18.4 degrees. What does that give you? Say again? Approximately 12 feet. Okay. And does that make sense? Should A be shorter than C? Yes, C's the hypotenuse. It's got to be the longest side. So sure, that seems right. Was that the only way you could have done that second part? You could have used Pythagorean theorem. I thought that Tyler, since he was so anxious to use it, he would be insisting on using it. But no, okay? If you had that answer. Now, here, if I were using that, once I had that C in there with all those digits in there, then I would have squared that. I wouldn't have rounded. Because once you round, then you're introducing round-off error. Use all those digits and square that, subtract from that 16, that will give you A squared, and then the square root of A squared, that will give you your answer. It should be about the same, as in almost exactly the same. All right, 12 feet. Any questions on that? If that's a little fuzzy to you, checkpoint does a very similar problem, a little bit different angle, different height, but very similar problem. Okay. There's a nice little activity type thing there that I'll let you look at, see if you'd like to pursue that. But let's move on to the vocabulary in 4.3. Match each trigonometric function with the right triangle definition. Okay, you have A, B, C, D, E, F up at the top, and then you have I1, I2, I3, I4, I12, IV, 5, and Roman numeral lowercase 6 at the bottom. So I'll call out A, you call out which one it is. Everybody got a book? No, you don't yet. Okay. What is a sine? What is its right triangle definition of a sine? We've already hit it today. It's on page 286. Vocabulary, top of the page. 4.3 exercise. Sine is? Which is? 5, okay? Cosine is? Which is? IV, okay? 4, okay? Tangent is? Okay, which is? 6, very good. Number D is cosecant? Which is? 3, excellent. Secant is? 1. Okay, hypotenuse over adjacent, excellent. And cotangent is? 2. Adjacent over hypotenuse, excellent. Number 2, relative to the acute angle theta, the 3 sides of a right triangle are the blank side, the blank side, and the blank.
Opposite, adjacent, hypotenuse.
Excellent, very good. Cofunctions of blank angles are equal.
Right.
No. Okay. Can't. Starts with the same 2 letters, CO. Not quite. We haven't even. Complementary, you got it. Okay. Cofunctions of complementary angles are equal. Very good. Number 4. An angle that measures from the horizontal to an object upward is called the angle of elevation, whereas the angle that measures from the horizontal downward to the object is the angle of, oh boy, I'm depressed. Okay, good deal. Homework exercises here, either 5 or 7, 9 or 11, any of the odds 13 to 19, any of the odds 21 to 29, any of the odds 31 to 39, any of the odds 41 to 45, any of the odds 47 to 55, any of the odds 57 to 61, either 63 or 65 or both, and any of the odds 67 through 77. You choose. As many or as few as you would like of those. I would say get some that you have the greatest interest in, or that would be most appropriate for your major if that's something that you think about too. The exploration, you're not going to see many true false on test or anything, but still it's a good idea to think through those. Okay, and then the 71 or 80, 71 to 83, think about it's 85, 87. Okay, so now we're ready for 4.4. Any questions on 4.3? Okay, 4.4 is trigonometric functions of any angle. Notice in the last section we only dealt with right triangles in the first quadrant, acute angles. Okay, so now let's move our scope to trigonometric functions of any angle, not just acute angles. Okay, what we'll do here is evaluate trig functions of any angle, and in so doing we'll learn about the reference angle. Okay, and then we'll evaluate the trig functions of any real number you want to write down there. Okay, so introduction. Okay, the definitions of trig functions were restricted to acute angles in the last section. They don't need to be. In this section, the definitions are extended to cover any angle. When theta is an acute angle, okay, that's what we were doing before, the definitions here coincide with the previous section. So this is taken just from the previous, except in the previous section we called, imagine this is an acute angle here. Okay, let me draw it in here. I think I've already pointed this out to you. Let's just imagine that we're doing that triangle there and we're looking at this angle theta. What were our definitions? If this is our right triangle here, right angle there, what did we call the three sides? You answered it earlier. Okay, I'll guess that's opposite, this is adjacent, and this is hypotenuse. Okay? We're going to rename those ever so slightly now. And I don't know what, well, maybe I do know why. But anyway, what is the opposite length here?
The same as the adjacent.
Same as what?
Adjacent.
No, that's looking at my picture. I'm talking about in general.
I don't know what you're asking.
Say again?
I don't know what you're asking.
Okay. Imagine this is a point here. What would we name that point? Maybe XY? Is that okay? Okay. What would the opposite length be? Okay. Y. The opposite length is the length Y, isn't it? The adjacent length is the length X. And what's this? That's hypotenuse, is what we've been calling it. Now we're going to start calling it R. Why? We're going to go back to the concept of the circle. Only this is no longer a unit circle, because this is not required for R to be 1. Because this is any angle. Okay? So how are we going to define that R now if it's not 1? Now, let's think this one. So let's change this to be your Y, X, and R. Y, X, R. How is this R defined? If you know the X and Y, you know that the coordinates of that point there, then you tell me what R is. How? Pythagorean theorem. What would it be?
X squared plus y squared equals 4 squared.
You got it. So R would be the square root of X squared plus Y squared, right? That's what R is. as such, R is always positive. Always positive. Is X always positive? No. It could be down here, over here, like that one is. Is Y always positive? No, it could be down here. But R is always positive. And with those new definitions, guess what? We can still talk about our trig functions just like we did before. On the unit circle, we used x, y, and 1. On the acute angles, we used opposite, adjacent, and hypotenuse. Now we're just going to use x, y, and r, where r is the square root of x squared plus y squared. Okay? And you'll see they're always the same. What is sine theta? What is sine theta? Y over r, cosine theta. X over r, tangent theta. Y over x, as long as x isn't 0, where is x equal 0? Yeah, when it's y-axis, what would that point be? What would that angle be? 90 or pi half, or also down here, 3 halves pi or 2/7. Okay. So as long as that x is not 0, that's where it is. Cotangent would be x over y, as long as y is not 0. So can r ever be 0? No. The only way r can be 0 is both x and y is 0. If that's 0, we don't have an angle. We don't have a triangle. We don't have anything. We have a point right there. We don't take three functions. Okay. So, now y can't be 0. Where's y 0? What two angles? Pi and 2 pi, or you could have said 0 and pi. And any multiple of those, integral multiple of those, yeah. Okay? So cotangent can't be 0 at your even pi's. Tangent at your half pi's. Okay? Whole pi's for cotangent. Secant? What is its definition? Second? R over x. Perfect. As long as x is not 0. X is 0 at the half pi's. And cosecant? R over y. As long as y is not 0, and that's 0 at the whole pi's. Okay. Or multiples of that. Okay. We've seen this over and over and over. It must be important, mustn't it? If they keep showing almost the same thing, get the concept. This is well used. Okay. So I ought to probably erase what I drew in. No, I meant to do this. That. Okay. It works over here when the angle is greater than 90. It doesn't have to be an acute angle anymore. Your sine is still x over y, it's just that happens to be x is negative now. But your x over r is always positive. So your sine is your y over r. Y is still positive here, r is still positive, so sine is positive here. Cosine, though, is x over r. X, though, is now negative, and so therefore cosine is negative. Tangent is y over x. Y is positive, x is negative. So tangent is negative here. Cotangent is x over y, so it's also negative. Secant is what's the definition of secant? R over x, but r is positive, but x is negative, so secant is negative, and cosecant is r over y, and y is positive here, so secant, or cosecant is positive. So guess what? Only 2 of the functions are positive here. All of them are positive here. 2 are positive here. Sine and its reciprocal cosecant. All the rest are negative. Down here, there is anything positive down here. Which one is relating x and y? Which of the trig functions deals only with x and y? positive here, only sine and its reciprocal cosecant, tangent and its reciprocal cotangent. How about over here? Over here, x is positive, y is negative. So anything that has only y and r in it, got to be negative. And y and x. But if it's x and r positive, what's the only thing with x and r? Secant and goes up. Exactly. Okay. More than they were asking for here, but no extra charge. Okay. Because, I've already said this, r is square root of x squared plus y squared. It cannot be 0, ever, ever, ever. It follows that the sine and cosine functions are defined for any real value of theta. Because guess what? They're always over r. Sine is y over r, cosine is x over r. R is never 0. They're defined everywhere. However, when x is 0, both the tangent and the secant, which is y over x and r over x, they are undefined. And, for example, tangent of 90 degrees undefined. Similarly, secant of 90 degrees is undefined. Similarly, when y is 0, the cotangent and cosecant are undefined because x is 0. Okay, we've already said that several times. So here's the first example. Let negative 3, 4 be a point on the terminal side of theta. Find the sine, cosine, and tangent functions of theta. What's sine of that angle theta? Does it help to draw a picture? I find that most of the time it does. Are y'all good enough you don't need it? Picture's fine. Okay, so let's do a little coordinate system over here. And that system has to have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay? And EJ's here. He was waiting for that example. Okay. All right. Show me where that point is. Tell me how to get there. How do we get there? Left 3. Okay, just don't say yours. Okay, got it. So here's the point, negative 3, 4. Okay. Hey, all right. So here's the angle we're dealing with. All right. How do we get the sine of that angle? Hey, what do we need? Can you write it down? Y over r, that's what it is. You're absolutely right. Y over r. I know, anyone know what y is? 4. Anyone know what r is? What's that? Anyone remember what the formula for r is? So long ago, say again? The square root of x squared, which is negative 3 squared, plus y squared, which is 4 squared, and that would be the square root of, what's negative 3 squared? 9 plus 16 equals square root of 25, which is 5. You got it. There's your 5. So we know what sine is. It's 4/5 or 0.8, whichever you want to do it. Okay, do you know what cosine is of that angle? It's what? X over r, which is, what's your x here? What did you say, negative 3? And your r is still 5, so this will be, you don't have to change it, that's why I just did, negative 0.6. You know what tangent is? is y over x, which is, second, 4 over negative 3. I'm just going to leave it like that. I don't want to write the other one. They didn't ask for it, but tell me what cotangent is. Second, x over y, which is negative 3/4. Very good. What's secant? Is r over x, which is negative 5/3. The negative's from the 3, not the 5. Okay, how about cosecant? R over y, which in this case is 5 over 4, which is 1.25. Don't have to write it that way, but yeah. Now, a couple of things to note, folks. Sine and cosine, always between -1 and 1. Could be -1, could be +1, never outside of it. Tangent and cotangent could be either. But when one is greater than 1 or outside of plus or minus 1, the other is inside plus or minus 1. Always, they're reciprocals of each other. Okay? And secant and cosecant, always outside -1 and +1. Either less than -1 or greater than +1. You see that's the case here. How many of these are positive? Two of them, sine and cosecant. Now, have I told you this little acrostic yet? How you determine that? Not how you determine, but it helps you remember the signs. Okay? The SIGN signs. All students take calculus or chemistry or whatever, or All-State Technical College. Whatever you want to remember that by, all of your angles are positive in the first quadrant. Only sine and its reciprocal, cosecant, in the second quadrant. Only tangent and its reciprocal, cotangent, and only cosine and its reciprocal, secant. So the rest of them are negative. Those other three quadrants. Make sense? All right. That was more than they asked for. They just asked for the first 3. But again, no extra charge. Okay, let's erase all the ink. And let's see how they did it. Referring to the figure, there's a, yep, they drew it first, just like we did. Maybe not quite as pretty, but close. Okay? And they got their x, -3. They got their y, 4. That was given. But they didn't know the r, so they had to calculate it. Square root of x squared plus y squared, which is square root of -3 squared plus 4 squared, which is the square root of 25, which, of course, is 5. Now that we have that, we can write all the trig functions. You have the x, the y, and the r. You can write them all. Your sine is y over r, which is 4 over 5. The cosine is x over r, which is -3 over 5. The tangent is y over x, which is -4 over 3. Okay. And then you can write the other 3 by doing reciprocals. Piece of cake. Cotangent would be -3/4. Secant would be -5/3. Cosecant would be 5/4. All right. Y'all need that any longer? Pretty easy stuff, huh? Now, the signs, SIGN signs, Chevette. Okay. Slowly getting there. We're on top of page 291. The SIGN signs of the trigonometric functions in the 4 quadrants can be determined by the definitions. I think we just said this. For instance, because cosine of theta is always x over r, it follows that cosine theta is positive where x is positive and negative where x is negative, because r is always positive. Okay. So x is positive in the first and the 4th quadrants. Negative other places. Okay? So it's positive whenever x is greater is always positive. So sine would be positive where? Second, first and second, because it's y over r, and y is positive in the first and second quadrants. Now, tangent and cotangent are a little fuzzier. Tangent would be positive where, because it's y over x, so it's positive where the x's and y's have the same sign. Same signs in the first quadrant, same signs in the third quadrant. So tangent and cotangent are positive there. And then all the reciprocals follow their other function. Okay. Yeah. In a similar manner, you can verify the results as shown. Yeah, we've just done this. Everything positive in the first quadrant, only sign of the first three, positive second quadrant, so it's reciprocal cosecant would be. Third quadrant, only tangent, and it's reciprocal cotangent. Fourth quadrant, only cosine, and it's reciprocal secant. Okay? And that comes from this, okay? Here, x is positive, y is positive, r is positive, everything positive. Over here, x negative, y positive, r positive. So anything that depends on x and r are x and y. So that's everything except sine and secant are negative. Down here, where x and y, it depends only on x and y, it's going to be positive. When it depends on either x and r or y and r, it's going to be negative. Over here, x positive, y negative. Anything that depends on x without a y dependence on it is going to be positive. And see. And these are the angle breakdowns in radians. 0 pi halves, pi halves of pi, pi 3 halves pi, and 3 halves pi. Okay, we've hit that many times now. Okay, they're skipping example 2 and 3. So let's see if we got room on some slide. Okay, let's do it here. Example 2. Okay. All right. Different kind of problem. This is a little more involved, so they skip it. So that makes no sense. Given that tangent is equal to negative 5/4. Now, if that's all they give you, that tangent is equal to negative 5/4, at least you can tell me, where are we, Waldo? Wait, there's got to be an angle in there. Tangent theta. Okay, sorry about that. Yeah, this thing is driving me nuts. Okay. Okay. Tangent theta is equal to negative 5/4. Where are we, Waldo? If tangent theta is negative 5/4, tell me what quadrant or quadrants we must be in. Help me. Third quadrant? Tangent is positive in the third quadrant, so it can't be third quadrant. Second, it could either be fourth or second or fourth. That tells you you're in either the second or the fourth quadrant, because tangent is positive in the first and the third quadrants. Okay, let's see what else they tell you. And they also tell you this, that cosine of theta is greater than 0. Now, what does that tell you? Where are you for that? Where is cosine positive? Greater than 0. Okay, James is here. If I can find you, I know you're on here. There you are. All right. So we're just missing Bajarian. Jasmine Moore must not be coming back. Aaliyah, and we're not sure about Sean. She may not be coming back either. Okay? Where are you if cosine is positive? Greater than 0. Where do you have to be? First or fourth? This says you're in either. This is either second or fourth. This is first or fourth. So where are you? Fourth. Got to be in fourth. The only place where the tangent is negative and the cosine is positive. Okay. So you know you're in quadrant 4. Okay. You know you're in quadrant 4. Now, it says find sine and secant. Now, frankly, folks, I think drawing pictures is the way to go. I draw really ugly, but I think it's the way to go. So let me draw a coordinate system here, and we'll do 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay? Now, it tells us that tangent theta is equal to negative 5 over 4. What is the definition of tangent theta? It's what? Y over x. If we're in the fourth quadrant, which of these is positive and which is negative? Say again? X is positive, y is negative. So we must be a plus 4, because that's in the denominator, and a negative 5, because that's in the numerator. So here we are, Waldo. Right there we are. This is your angle theta. Okay? Now, we didn't need the picture, but maybe it's helpful to you. So this point here is x is positive 4, y is negative 5. Okay? Now that you know those coordinates, you need one more piece of information. What's that? R. You need R. What is your R? Square root of x squared, which is 4 squared plus negative 5 squared, and that would be the square root of 16 plus 25, and that would be square root of 41. Not a perfect square. Okay, so you can't do anything else except use square root of 41. So can you tell me now what sine is? What's its definition? Y over R. What do we say the y was? Say again. Negative 5 over, and your R was square root of 41. Now, if you want to leave it like that, it's all right with me. If you don't like having radicals in the denominator, that would be negative 5 root 41 over 41. If you like that better, go for it. How about secant? What is secant? What's its definition? R over x. And that would be square root of 41 over 4. Positive fourth quadrant, that makes sense. Sine, negative, fourth quadrant, that makes sense. Now we could do every other one of them. What would the cosine be? Four over root 41. What would the tangent? We know it. They gave it to us. Negative 5/4. Cotangent would be negative 4/5. We just figured out what secant is. What would secant be? Negative root 41. Very good. Y'all got them all. Okay. Let's see how they did it. They got sine to be negative 5 over root 41. They left it like that. They wrote it as an approximate decimal number, but they didn't rationalize the denominator. And secant was root 41 over 4. Okay. Good deal. Any questions? Make sense? All right. Good deal. All right. Neither did they do example 3. So let's do example 3. Evaluate the cosine and tangent functions at the 4 quadrant angles. Theta equals 0, pi halves, pi, and 3 halves pi. And we want to evaluate the cosine at each of those and the tangent at each of those. So let's start with 0. Cosine of 0 is equal to, second, cosine 0. Second, x over r, okay. Certainly you can do it that way, or when picture the circle here, what is the value of x at angle 0? Second? Okay, on the unit circle it would be 1. On any old circle that would be, this is r, this is x equal r, right? Whatever that radius is, when the theta is 0, the cosine is x over r. That would be r over r, which is 1. Okay, feel like a dentist. What is tangent of 0? Zero over 1, or 0 over r, which is 0. Okay, how about the pi halves one? Cosine of pi halves. X over r. That's 0. Very good. The tangent is at pi halves. Second? Undefined, right. Okay. How about pi? Cosine of pi. -1, perfect. Tangent of pi. 0, because its opposite is 0. Okay? And the cosine of 3 halves pi. That's 0, and the tangent of 3 halves pi, undefined. Got it. Make sense? Okay. They went back to the unit circle. It's fine. I like to keep it as r, but it doesn't matter. Unit circle is fine. They do have a checkpoint there if you want to deal with it. All right. Any questions? Any questions on that so far? Everybody got it or still getting it? I'll move on. Okay. All right. Next, we're going to talk about reference angles. Okay. You just did one way of finding any trig function of any angle. Identify the coordinates, figure out what the r is. If you draw the picture, you see which quadrant you're in, and go with the signs from there. The values of a trigonometric functions of angles greater than 90 degrees or less than 0, so either negative degrees this way or any angles beyond 90 degrees that way, can be determined from their values at a corresponding acute angle. If you're used to and like and are comfortable with acute angles, then those are reference angles. Now, if it's an acute angle, what's the sign, or what's the SIGN sign of any of your trig functions for acute angles? Positive, because you're in the first quadrant, right? So basically what you do, if you figure out what the reference angle is, it's going to be a value, a positive value. Then figure out which quadrant you're in and what the sign of that quadrant should be, and then give that sign to it. So the definition of a reference angle, let theta be an angle in standard position that's measured from your positive horizontal axis. Okay? The reference angle is the acute angle, theta prime, formed by the terminal side of theta. So the terminal side of theta is in the first quadrant. That is your angle. Okay? If it's in the second quadrant, the terminal side is over here in the second quadrant. This is the acute angle we're talking about. If it's in the third angle, it's always with the horizontal. That's the angle. Fourth quadrant, it would be that angle. Okay? So it's formed by the terminal side and the horizontal axis. Your reference angle is always measured to the horizontal axis, the closest horizontal axis, the acute angle. Okay? So here's what I was just trying to finger paint over here. If this is your angle theta, here's your reference angle theta prime. Always from the terminal side to the closest horizontal axis. If you're in the third quadrant, here's your angle theta. Your reference angle is from the horizontal axis to that terminal side. If you're in the fourth quadrant, here's your angle theta. Your reference angle is the angle between the horizontal axis and that terminal side. Okay. Now, looking at those, you can see a relationship. It's not always the same relationship, but look at them and in a given quadrant, it's always the same. So let's start in the first quadrant. The reference angle is the angle, because that's the closest acute angle to the horizontal axis is that angle. So they're the same in the first quadrant. In the second quadrant, though, here is the angle, theta, and we see that if you add the reference angle to it, you're going to come up to pi, or 180 degrees. So going backwards, 180 minus theta, that's your theta prime. Or pi minus theta, that's your theta prime. So in the second quadrant, this is the formula you use. One of those two. If you're radian motor. Do I memorize this? No. I'll look at the picture and say 180 minus this is that. It's just there. Okay. Now, if you're in quadrant 3, your reference angle is here. Here is the angle in question, the given angle, theta. The reference angle is that theta minus 180. That leaves you this part right here, or this angle minus pi. That leaves you that angle. So it's theta prime, it's theta minus pi, or theta minus 180. Look at the picture. It basically tells you what it's got to be. Over here, this one, you tell me what does that mean. What is the relationship between the angle theta and the theta prime? Here, mumble. 360 minus theta is going to give you that reference angle. Absolutely. You're reading my hand. Okay. So 2 pi minus theta or 360 minus theta. That's it. The sum of those two angles is 360 or 2 pi. So subtract the 360 minus the angle. That's your reference angle. I don't remember those little equations. I just look at it and see. Oh, it's the sum, it's the difference. Okay. So, let's find the reference angle for each of these angles. If you go by the formula, you can do it directly. If you want to draw a picture, it makes it really obvious. Okay? Let's do the A one. Where are you if you're 300 degrees? Which one? Fourth quadrant. Absolutely. Okay? Where in the fourth quadrant? Especially think horizontal. How far are you short of 360? 60 degrees. There's your reference angle. That's your theta prime. See how it is? You go. It's you're 60 degrees short. If you're 300 degrees, you're 60 degrees short of 360. Okay? This is an interesting one. Let's do a different color. Give me a color. Red. Orange. Okay. Now, this is, it didn't take. Orange. There we got it. Okay, this is the orange one. Okay. Theta is 2.3. What in the world is 2.3? What's that? What is 2.3? What's that a measure of? It's what? Radians. You don't see a degree symbol, it's got to be radians. What is 2.3 radians? Give me a reference. Name a radian, we know what it is. 2 pi. Okay? 2 pi would be from here to there. And what number would 2 pi be approximately? Say again?
360.
Okay, yeah, but give me a number that, pi is a number, right? What is that number? 3.14. Okay, right, you got it. Now, that's your pi. So 2 times that would be something like 6.28 or so. So that's way bigger than this. But you just said pi is 3.14. That's still bigger than this. Half a pi, though, would be 1.5 something, 1.57. So that's less than this. So if you're less than pi halves, greater than pi halves, but less than pi, where are you, Waldo? Second quadrant. That's what you need to figure out. You're in the second quadrant. Okay? So what would be your reference angle? You're somewhere over here. Where's your reference angle? Always measure to the horizontal axis. There's your reference angle, theta prime. You just got to figure out what it is. Well, they told you this angle, theta, is equal to 2.3. So what is that reference angle? What is this angle here? Pi. So this would be pi minus 2.3. And you can leave it like that if you want to, or you can write pi as 3.1. Minus 2.3 would be 0.8. Now, the book does something really bizarre. They carry a lot more digits. If you're only given 2 digits, don't give me an answer of more than 2 digits. That's why I rounded the pi to 3.1. Okay? So, that would be what that would be. Approximately 0.8. The theta prime is approximately 0.8. And like I said, the book's going to give a lot more digits than that. Okay, where are you, Waldo, if theta is negative 135? Say again? Third quadrant, how did you get that? Okay, this is minus 90 down here. This would be a minus 180 over here. You're somewhere in between minus 90 and minus 180. In fact, you're halfway in between those, aren't you? So you're right here. Whoops, what color you want this one? Say again? Green. Dark or light? Dark. Okay, we'll go with dark green. Okay, you're somewhere in the third quadrant here. So here's your theta is equal to negative 135 degrees. How are you going? Where is your theta prime? from there to the horizontal axis. There is your theta prime. Or whichever way you want to put the angle, I don't care. It's a positive acute angle, okay? So how do you get it? From 180. So make everything positive. 180 minus 135 is 45 degrees. Yeah, halfway in between. Because remember, your reference angles are two things, acute and positive, okay? Never put it down as a minus, never have it greater than 90 degrees or pi halves, okay? See how it works? Any questions? Okay. Let's erase all that ink and see how they do it. They do it by the formulas. Because 300 degrees lies in quadrant 4, yeah, we determined that. The angle it makes with the x-axis is, and they use the formula, and that gave you 60 degrees. I like drawing the pictures, and it basically smacks you and says it's got to be 60 degrees. We got that right in degrees. And then they drew the picture. Draw the picture first, okay? And then see what the angle's got to be. Got to be 60 degrees to continue from 300 to the horizontal axis, okay? Because 2.3 lies between pi halves, which is 1.57, and pi, which is 3.14, you're somewhere in the second quadrant. So the reference angle is the difference between pi and that. And look how many digits they give you. Ridiculous. If it's 2.3, how can you get 4 digits there? If you only have one decimal place in your given, you can't have more than one decimal place in your answer. Okay? And this shows it. You're in the second quadrant, and the reference angle is pi minus that. To get the pi, you'd have to add another 0.8 to the 2.3 to get you close to pi. And the C part, first determinant negative 135 is, okay, they made it coterminal. You can do it that way. I like the way you did it. You just said that's over here, okay? 225, which is in quadrant 3, both same thing. So the reference angle is the difference in 225 and 180. Or, looking at your picture there, the difference between 180 and 135. Either way you do it, it's going to come out being 45 degrees. Got it? Okay, and here's the picture. There's your negative 135. There's your positive 225. It's 45 degrees from horizontal. Okay. Banker's hours, huh? Okay. All right. I didn't say that, did I? Okay. I did too. Okay. Now let's do trigonometric functions of real numbers. Isn't that what we've been doing? Well, yes, it is. To see how the reference angle can be used to evaluate a trig function, consider the point xy on the terminal side of theta. We've seen that pretty much before, right? Well, for the life of it, I don't see why they should both of these, but if it helps you to understand. If you want the trig function of this, it's just like before. Use x, y, and r. You got it. Okay. But if you're not as comfortable with that, then what you do is notice that your theta prime here, and it's going to be in every quadrant that way, is when it makes an angle with the horizontal axis, then that gives you your y being your opposite value, which is what we were saying before. The x is your adjacent value. The only thing is it's now the absolute value of that x. Because this x is actually negative. The adjacent side would be this, and the hypotenuse would be that. So you go back to the same thing you did before. Here it was, in this quadrant, it's unnecessary to say absolute value, because y is positive here. But down here or here, you would use absolute value. So keep it general and do that. So you can do it this way. So if those angles are easier for you to think of, rather than the bigger angle theta, x, y, you know, plus, minus and stuff, do that. Either way you do it, it works out right. Okay? Now, you know by definition that the sine theta is y over r, tangent theta y over x. You know all that. Why did they bring that up? Oh. I guess this is just an example of what they're doing. For the right triangle with the acute angle theta prime, the sides of those are opposite and hypotenuse. That would be absolute value of y over r, and the tangent would be absolute value of y over absolute value of x. Of your theta primes, these are guaranteed to be acute angles, so you can do the same thing you've always done with acute angles, and then at the end, go back and put the SIG in sign if it fits. So it follows that the sine theta and sine theta prime are equal in value, except possibly the sine. The same is true for tangent and tangent theta and tangent theta prime, and for all the other four trigonometric functions and their reference angles. In all cases, the quadrant in which the theta lies determine the sign, SIGN sign, of the function value. Okay? Evaluating trig functions of any angle. To find the value of a trigonometric function of any angle theta, determine the functional value of the associated reference angle, theta prime. That will always give you the positive value of it, and then depending on which quadrant you're in, affix the appropriate sign for that function value. You know what those rules are. Okay. You can greatly extend the scope of exact trigonometric values. That's what I was sort of hinting at before. If it's some of those favorite ones, for instance, knowing the function values of 30 degrees means you know the function values of all angles for which 30 is a reference angle. So guess what they're going to give you? This table again, okay? We've seen it before. We'll see it again over and over and over. Know this. Get to know this, okay? Now, if your theta's in either degrees or radians at 0, those are the same. Sine of 0 is 0, cosine of 0 is 1, tangent of 0 is 0. Okay? Now, move on to 30. Degrees, pi 6, radians. Sine is 1/2, cosine is square root of 3 over 2, and tangent is square root of 3 over 3. Okay? Actually, I sort of like to go down this way. Okay? Sine of 0 is 0, sine of either 30 degrees or pi 6 is 1/2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2, which is 1, 0, minus 1. Okay? Cosine. 0 is 1. This counts backwards. Square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, square root of 0 over 2, and then minus 1 is 1. Then the tangent function, and then all the others are going to do like this. 0, and then what I do, 1 over root 3, which is square root of 3 over 3, root 2 over root 2, which is 1, root 3 over 1, which is root 3, 1 over 0, undefined, 0 over 1, 0, and negative 1 over 0, undefined. Once you have the table set up, tangent's easy. Just be sine over cosine. Okay. They've done this about 3 different times now. Get to know these. Really nice, important to know. All right, let's see if we can do these fairly quickly. Cosine of 4/3 pi. And there's several ways you could do it. They don't say you have to use reference angle, but you can if you want to. Or you can use whatever you want to use. Where are you, Waldo? 4/3 pi. Any ideas? First thing that pops in your head when you see 4/3 pi. Third quadrant. Why? You're beyond you're beyond pi, right? How far beyond pi are you? 1/3 pi, right? And what's the cosine of 1/3 pi? Second, it's the same as 60 degrees. Oh man, ugh, it hurts so bad. Say that again.
240.
Okay. Why are you putting yourself through all that agony? Don't you know it in radius? 1/3 of a pi is 60 degrees. What is the cosine of 60 degrees? We just, say again? Okay, no. Cosine of pi thirds is 1/2. Okay. If you got an angle in pi, your answer is not going to have pi zone usually. Okay. So that would be the same value as the cosine of pi thirds, which is 1/2. But you saw me, what quadrant are we in? Third. What's the sign of cosine there? The SIGN is cosine. Negative, so it's negative 1/2. That's all you do, okay? Sorry, we've run out of time. Oh, I'm sorry. I let April get out too soon. We will start the next one with the B part, okay? But for your viewing pleasure, I went on and had the test made out because we're not through with 4.4. And by the way, we're that close. I mean, we're awfully close. With any of the odds, either 9 or 11 or both, any of the odds 13 to 17, either 19 or 21 or both, any of the odds 23 to 31, either 33 or 35 or both, any of the odds 37 through 43, any of the odds 45 to 51, any of the odds 53 to 67, any of the odds 69 to 73. We'll stop there. We'll pick up the rest of them later. But since we came so close to finishing 4.4, we're going to made out the test so you have an extra weekend now. Okay? So here is your test. Will anyone see Amber again? Before all right, if you'll see her, I'll give her one, or anyone else who was absent today. Okay, if you see her, tell her I've got it, she can come get it. Just give you an extra weekend to work on it. Okay.